Homothetic preferences. So let's talk about what are homothetic preferences, and let's do a simple proof and the definition around that. So let me just write a simple meaning of the homothetic preferences first. So what are homothetic preferences? So let me just draw this. So you have x2 out here, you have x1 out here, and these are the two rays from the origin. One is this and other is, let's say, this. And you have drawn several indifference curves, right? You have drawn several indifference curves. Well, if you take let's say if you take, let's say, the slope of the indifference curve along this, so the slope of the indifference curve is same here, is same here. So along this red line through the origin, the slope of the indifference curve is same, and along this green line through the origin, okay, I need some other color so that I make my point like this. So along this green line through the origin, the slope of the indifference curve is same. Let us write slowly. So what is it that we have learned till now? That a preference relation is said to be homothetic if the slope of indifference curve remains constant along any ray from the origin. So we'll know about the homothetic preferences as we move deeper into the video. So up until now, one thing we have learned, that there is an indifference curve, the set of indifference curve, and if you draw a line right through the origin, if the slope remains along that, if the slope remains same along that line, then such a preference relation is going to be homothetic. Now, what do you mean by this? So what is the importance of knowing this? So if you have such kind of the homothetic preferences, so if you know the shape of one indifference curve, then you would also know the shape of the other indifference curve. The entire indifference map you would know for the homothetic preferences, because you know that this since these slopes are going to remain same along the ray from the origin, so the shape of the indifference curve would also remain same. So if preferences take this form, then knowing the shape of one indifference curve tells you the shape of all indifference curves. Since they all are radial blows of each other. हाँ बेटा, since they all are the radial blows of each other. So if you know one indifference curve and then you know that these preferences are homothetic, so if you draw any ray from the origin and you take the slope of the different indifference curve along that ray, that slope is going to remain same. So you know this fact. So if you know this, then you know the entire indifference map. That's what is being said. Now formally, how you can say, so there are different definitions I'm going to give for these homothetic preferences. So formally we say a preference relation is homothetic, right, if for any two bundles x and y we have such that x I y, right, then alpha x is alpha I y. Now what is this I? I is indifference. So you are saying that if there are any two bundles x and y and you are indifferent between these two bundles x and y, and if the preferences are homothetic, then you would be indifferent between 2x and 2y also. You would be indifferent between 3x and 3y also, tx and ty also, alpha x and alpha y also. You with me? So that's what is being said. So let me just write this in English. What I mean by this, suppose that consumers' preferences are only dependent upon ratio, of good 1 to good 2. So of good 1 to good 2. So if consumer prefers beta x1 x2 to y1 y2, then what Varian says, then she automatically prefers 2x1 2x2 to 2y1 2y2, right? Then she automatically prefers 2x1 2x2 to 2y1 2y2 to 2y1 2y2, right? She prefers 3x1 3x2 to 3y1 3y2. The ratio is same, right? So and so on. So ratio is same for all the bundles which you have just written. So you prefer x1 x2 to y1 y2, you automatically prefers 2x1 2x2 to 2y1 2y2 if your preferences are homothetic. So since, and why she does so, because since the ratio the ratio of good 1 to good 2 is same for all of these bundles. So in fact, consumer prefers Tx1 Tx2 to Ty1 Ty2 for any t greater than 0, and in case if this happens, then such preferences are called homothetic preferences. Let me give you one formal definition, again one more definition of homothetic preferences. So what you're saying is this definition. A definition for homothetic preferences. Right? A strictly increasing function ux is homothetic if for any x0 x1 and theta greater than 0, if u of x0 is greater than equal to u of x1, then u of theta x0 would also be greater than equal to u of theta x1, right beta? So u of theta x0 is also greater than equal to u of theta x1. So this is basically the same thing, don't you think? So if you prefer x0 to x1, then if the preferences are homothetic, then you also prefer theta x0 to theta x1. So in the form of utilities, how do you write it? If you prefer x0 to x1, you write ux0 is greater than equal to ux1, and if preferences are homothetic, then you also prefer theta x0 to theta x1. So how do you write this in terms of utility? U of theta x0 is greater than equal to u of theta x1. That's what you write, right? So how do you say? If individual is indifferent between two bundles, let's say, between two bundles x0 x1, then ux0 is greater than equal to ux1, and at the same time ux1 is greater than equal to ux0. I hope you know this. That is, if the two things are indifferent, if suppose for example, if x0 and x1, you are indifferent between x0 and x1, then the utility which you derive from x0 is equal to the utility which you derive from x1. So instead of just straight away writing ux0 is equal to ux1, so what you are writing is ux0 is greater than equal to ux1, and at the same time ux1 is greater than equal to ux0, which implies ux0 is equal to ux1. Well, if preferences are homothetic, so you can say u of theta x naught is greater than equal to u of theta x1. That's what you've just said. If preferences are homothetic, if you prefer x0 to x1, then you also prefer theta x0 to theta x1 for theta greater than 0. Then, and at the same time, u of theta x1 is greater than equal to u of theta x0, right? Therefore, if u of x0 is equal to u of x1, this would imply u of theta x0 is equal to u of theta x1. So, what you have done, you have proved if u of x0 is equal to u of x1, then u of theta x0 is equal to u of theta x1. You can prove by a similar argument, if u of x0 is strictly greater than u of x1, then u of theta x0 is also strictly greater than u of theta x1 if preferences are homothetic. And combining the two, you can say that u of theta x0 is greater than equal to u of theta x1, then, if u of x0 is greater than equal to u of x1, then u of theta x0 is also greater than equal to u of theta x1. So, by an identical argument, you can say if u of x0 is greater than u of x1, then u of theta x0 is greater than u of theta x1. So, this is the formal definition of homothetic preferences, right? This guy is the formal definition of homothetic preferences. Now, I have more to say about homothetic preferences. We will do one more definition of homothetic preferences, and we'll do few examples in tomorrow's recording, right? Thank you, beta.